and a warm welcome to today's hands-on bootcamp where you will get to build a fully working application in just under 30 minutes. I am Shmita Ramkumar and I'm the Director for Community and Partnerships with OpenWeaver. OpenWeaver is a SaaS technology company supporting over 1 million developers worldwide build their ideas faster by reusing open source software. Our vision is to reinvent digital realization. Very simply put, we'd like to improve the way applications are built. We do this by investing in a unique combination of both public domain knowledge and artificial intelligence. So coming to today's bootcamp, this is an integral part of our OpenWeaver community initiatives. The OpenWeaver community is a body of like-minded technology enthusiasts and open source contributors who have come together with the vision of contributing to the world of open source and sharing how complex use cases can be developed by reusing open source. Over the last few weeks, we have run several such open source development bootcamps on a variety of topics, such as building your own AR-powered e-commerce site, building your own ChatGPT, building a breast cancer prediction engine, building an object detection engine, basics of Python programming, and many more to come. Through these bootcamps, you will realize that technology does not have to be complex and definitely does not have to be developed in silos. You will see how you can take a solution that is pre-built, in fact pre-built by many people in the world, and then you can build on top of it and share it back such that your solution can now be accessed by many other people in the world who can then further build on top of your ideas, thereby accelerating this virtuous cycle of innovation and also helping you scale your ideas and bring it to life much faster. So with that brief introduction, I will now welcome our mentor for today's session, Pooja Agarwal, who is a senior developer advocate with OpenWeaver.
Hello everyone, welcome to today's session on breast cancer prediction engine. So we will understand how you can build a breast cancer prediction engine using artificial intelligences and using support vector machines as your algorithm. So let's get into agenda for the day. First, we'll talk about this problem statement and how it has impacted the world. Then we will do simple coding exercise and also understand why and how we can do prediction, your predictive analysis using support vector machines. And then we will discuss the entire solution as a whole using the Kandi kit. So before we get started and discuss the concepts, I would quickly want to showcase you the resultant output that you will get through today's bootcamp. So this is the current page where you are viewing our session today. And as you scroll down, you will see here under the resources section, you have your Kandi one-click kit button. So this is an option to get to your Kandi kit. Also, there is an option for doing simple coding exercises I'll discuss with you alongside in some time. And then you have an option for your assessment. In fact, I would also like to inform you that there are some interesting polling questions available on the platform that you can engage yourself with as we discuss and understand through this session. So that way, you will be able to also understand what grounds you're currently sitting on as per your knowledge and also engage with these interesting questions to be able to question yourself on your understanding and further learning as well. So now let's understand our today's solution source quickly. So we'll be following some quick steps in this very interesting simple solution using support vector machines. So before I discuss the entire solution with you, I just want to tell you that we have been able to get to a very decent accuracy of 96.4% with this interesting use case of breast cancer prediction. And that's how we have used various different classification parameters such as precision, recall, as well as your confusion matrix. So I'll talk about all of this later, but we have evaluated the model decently based on these parameters to help us state that we are having a decent solution in hand. So stay tuned with us. Let's understand how you can set up this kit onto your systems. So I hope you are already there on this community page where you are currently viewing this session. And another resources section is where you have to go ahead and click on the Kandi one click kit. This will take you to the kit page. On the kit page, you will see that there are deployment instructions listed down. And as you go ahead and click on the one click installer, it will download a zip file. Just say show in folder. So as you say show in folder, it is important to always extract this zip file. After you have successfully extracted the contents of this zip file, only then go ahead and double click the folder. And within this, just say double click this kit installer, say more info, and say run anyway. So this will start setting this kit onto your systems. So basically what we are doing, we are directly setting up this kit for you so that the Jupyter notebook should open in front of you after all the required dependencies are set up. The requirement for Python, the requirement for scikit-learn and other libraries, all of that, Jupyter notebook, etc., will already get set up onto your systems. So this way, let this installation happen. You can check the progress here. So minimize the screen, and now let's get into the concepts for today's session. So we want to talk about the world statistics on cancer and how it has breast cancer and how it has affected women all throughout the world. So if we see based on the stats that are provided by the International Agency for Research on Cancer and World Health Organization, this is a cancer. Breast cancer is something some which is not specific to a region, but it is spread out evenly in every region of the world. And the estimates that were there were some estimates and there was information that was generated as well as collected, based on which we found that more than 2 million new cases were recorded just during the year 2020. And if you see, it's Australia and New Zealand where you see that there is a lot of women and as well as men. So it not only affects women but it also affects men. So you shouldn't be thinking that only your maximum population that gets affected is obviously women. And 1 in 8 women in the US are have been at least have been diagnosed with a breast cancer in her lifetime. So that is actually a number that requires to be tackled and worked around with as a solution. In fact, every 46 seconds somewhere in the world they are saying that people or someone dies from breast cancer. So if you include proper stats, then 1876 men and women per day are affected from it. Hence, we want to tackle this problem. We are not saying that we are eradicating it or we are trying to give a complete solution to it, but we are saying that with this solution, you will be able to, or your medical person will be able to state whether a particular tumor is cancerous or non-cancerous with a decent 96% accuracy. So that will help in augmenting the knowledge in a way that better prediction and early stage detection is possible for breast cancer. We will use machine learning primarily as our tool here, and in that we will be going with, so we have both supervised and unsupervised category. In machine learning we will be talking about a problem where I have either the tumor as cancerous or non-cancerous, which is a classification problem, and that too requiring two categories or two classes. Okay, so when I talk about a supervised mode of learning, when we are saying we are inculcating the machine with the intelligence where it is able to behave like us as humans, in supervised mode of learning, I provide the machine with the data as to what is expected as an output. So what usually happens, either you provide the data set and you don't provide what is the expected output, then such a case you call it unsupervised mode of learning. But here, in the supervised mode, you have you provide the data set and you also provide the expected outcome. Okay, you provide the data set as well as the expected outcome, and it is known as a supervised mode of learning, wherein you have your classification and regression as two further categories of algorithms. So we will be working around with classification today, because I have a binary classification problem today, where I just want to say that a tumor is malignant or benign. So malignant is cancerous and benign is non-cancerous. We directly come to how are we going to tackle this problem. So we want to use this popular support vector machines as an algorithm. If you go ahead and check out the research papers, you would see that support vector machines is one of the algorithms that has been able to primarily target your problem in a way that it is able to give good results. So what is support vector machines? We are currently working with the linear SVM classification model, and the way in which this algorithm works is, we try to draw a maximum margin or a best fit or a best line decision boundary to separate the two classes or the two categories in which your different features, based on the different features, we want to state that whether a cancer, whether a tumor is cancerous or not. So all these square blue boxes is class 1, and all these pink circle boxes is another class, say class 2, cancerous and non-cancerous. So we want to be able to get to a space, a line. We want to create a best line or a decision boundary such that it is able to separate your data points and make it easier for you to say, based on if these features have this value, then your model will be able to predict and say that the tumor is cancerous or non-cancerous likewise. But supposedly, how am I going to get to this line? What makes it easier for me to draw this best line or a decision boundary? So for that, I have support vectors or margin vectors. If you see, those points which lie at the end of the class in the hyperplane, in the positive hyperplane, the point which is lying closest or farthest from the positive hyperplane but closer to the negative hyperplane, that acts as a support vector. And another support vector that lies farther in the class 2, okay, the pink circles, the one which is farther in the class, at the extreme end, will act as the one that will help us draw, the support vectors. And then you could also imagine that this line, currently we have drawn the slanting support vectors, depending on the line that is able to give us the maximum distance segregation separation or a decision boundary, will be the best fit line, okay, or will be the best line. So it is important that I just don't draw a straight line which is able to say it is in class 1 and class 2 separated. No, I want a line which is at the farthest distance from both these classes, at an equal and a farthest distance from both these classes, and is able to segregate these two in n-dimensional spaces. Okay, so with the help of these extreme points or your support vectors is how I draw the maximum margin hyperplane or the best fit line, which helps you in simply stating with a good accuracy that based on certain features, a tumor will be cancerous or non-cancerous. So what we will do, we will first need to train our algorithm with the help of a data set, and then we want to make predictions based on the training data that we had provided, how well our prediction is happening. So before we go ahead and actually check out the solution, I would like to do a quick coding exercise with you guys on how you can train test split. Okay, how you can train test split. But for that, we would want to get our solution source. opened. So by now you must have reached this space, this space where it is saying that the model has set up, or model has downloaded to 100%, and all these dependencies are installed, repo is downloaded as well as extracted. So we will just say yes and enter. This should open the Jupyter notebook directly onto my system. So once the Jupyter notebook opens, what you got to do, you simply go ahead and for now say new notebook. The reason for this is I want to do a simple coding exercise with you guys. Okay. And in the simple coding exercise, we want to do a train test split. So for that, what I will do, I'll go back to this community page. Okay. I'll go back to this community page and I have an option to directly click here on kandi.openweaver.com. Or you can also choose to click on this code snippet button. All of these will take you to this option to do a search. So on this search bar, I will type my query, what kind of a function I need. So what is this space? So I'll tell you about this space as well. This is a space where you can search for functions, simple code, libraries, kits. It will give you all of them together, but then you choose what exactly is your requirement. So let's say I need a function for train test split in Python. I will write these keywords and hit enter. I will see that it is giving me option for code snippets, libraries, kits, etc. So as of now, I will just go ahead and choose code snippets because currently I'm just willing to look for code snippets, and then scroll down and see a suitable code snippet that I can just simply copy paste and try and run onto my machine. So when I see this code snippet, it looks good enough. So we'll just copy it, paste it here in this notebook, and now check this for correctness. So what we have done, first we have imported the NumPy library, which we have given an alias name of NP, short name for NP. And then from sklearn.model selection, we have imported a train test split class. So this is important so that I am able to split my data set. What is this required for? This train test split, this helps in dividing your data set into training, testing, and then you are able to use it, some portion of your data set, let's say maximum percentage of your data set you will use for uh, training, and then you will leave, let's say 30%. After 70% you have reserved for training, 30% you will leave for testing, and that 30% will help you do the prediction and say whether you are able to train the model well or not. So here we have just taken this nd array, and with the array, we have this first one where we have 250 rows and two columns, and this one has 250 rows and one column, simply assigned to your x and y. So then when we call this train test split that we had imported here, we apply it on the x as well as y, and then give a test size. So this is basically what, if you if I just run this, since I have not given any command for print, I just have to say print this. Okay. And so what it is doing, it is just printing. Let us just print all of this for our convenience. Okay. And then we will talk about the result that is being showcased. Okay. Okay. So now I think we'll be able to clearly state what is being displayed. So this is a very simple two-line code that I copied, and then I saw that I want to print whatever is whatever I have tried to split my 250 cross 250 rows, two columns, and 250 rows, one column. What I have done, this train X is storing the X parameter for my training. Train Y will have my Y parameter for training. So then I have printed my so this data set train X dot shape is splitting. First of all, it has done a split. And what is the test size that I have given? 130. And what was the total size? 250. So if testing is 130, how much is left for training? 120. Okay. So you can change this as well. Let's say I just keep 100. And then I will remove this comment. Okay. So then you see simply 150 is reserved for training and the 100 is kept for testing. I can just vary this to 80 as well and then again run it. So whatever is the test size, like it was 250, test size is deducted from it and the remaining is kept for training. So that that gets into the train X. Then you have your test X. Okay, so your test X is how much? 80. Correct, this is fixed, right? 80. And then you also have your train Y and test Y. So your Y is this array, correct? This is your Y. So your Y train Y dot shape, again when we have set the test size as 80, so then that will also come out to 170, but this has just one column and then the remaining is for testing, which is again 80. So this is a simple demo of a code that you can pick up as a code snippet from, by making your search here on the search bar or clicking on this kandi. In fact, we have also listed down the direct links if you would like under the code snippets, train test it, and an exercise that you can go ahead and work around yourself later. So you can go ahead and work around the confusion matrix display as well later if you would like. We've given you the link for this as well. So one exercise is what we have just done to showcase how you can split your data set into training as well as testing parameters. Okay, now we will go and understand what is happening in our kit. So I will just say restart and run all. Okay. Yeah, we start and run all, and then we have seen that initially we are importing all the essential matrix here. So let's say from sklearn I have imported the data sets. Correct. So sklearn is scikit-learn is what? It is one of the framework that is used for primarily working with machine learning models with it's a framework which has data sets. It has all the algorithms that are required. Everything that is being required is stored or is already present in sklearn. Okay. And then that's how we are loading the model selection for train test split as well. Then further, we also import our algorithm, which is SVM, support vector machine. And then the fourth library is your matrix. So based on these matrix is what you will say that the model is performing well or not. Next step is we first need to load our data sets. So these data sets that we had called from sklearn is what we will use. And then within this data set, if you see, it will mention that this sklearn.dataset module includes utilities to load datasets, including methods to load and fetch popular reference datasets. So it is already present. How do you generate this intelligence? Just say shift and tab. And then when you press tab here, it will give you an option. Okay. It will give you an option to load, this breast cancer dataset is what we will load. After selecting, you have diabetes, you have your iris dataset, which is also used in various use cases. There is your wine, and various other data sets that you would maybe want to load. Okay, so we've loaded this breast cancer data set and set it on the cancer variable. Then we want to check out the data set, what is present in the data set. How do I know what features are there? How do I know in the supervised learning what is the outcome, like what are the two output that I can expect from this data set? Okay, so first of all, with the print, I have used that same variable cancer, and then I have used dot feature names. So this is again inbuilt, okay? When you have set your data set on this, it will give you an option, right? Either you go for feature names or you go for target names. So I just want to check out my feature names, right? Just use tab and then it will give you what all are the features. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then there are so many features that are available here. And then when you go to the labels, what are we calling labels? These are your output that you can expect from here. So you go for the output and you see that you have two outputs, malignant and benign. So malignant is a medical term where they are saying that the cancer is the tumor is cancerous, and benign is when the tumor is non-cancerous. So we want to only determine the tumor as cancerous and non-cancerous. Then we come to the step that we just did, okay? What did we do? We loaded this method train test split. And within this train test split, if you use this shift tab, you would be able to see these are the different parameters that are available, okay? That you can modify. And in fact, you can read about these as well in detail. All of the information is provided here. Even the examples are also provided here for you to understand. So as of now, I'll explain that this is your cancer.data, your X parameter, your target parameter cancer.target, which is your Y parameter, and then you have your test size. So 0.3 is 30%. So 30% means 70% will be used for training. And then random state is also one of the parameters that you can use to randomize the split. Okay, that you can use the data will get randomized and then it will get split. So you will get the X train, X test, Y train, and Y test. All these four from the train test split. Then you will use your svm dot svc. Okay, so then there is various options that are available. So with your svn, again you press tab and then you will be able to have linear support vector classification, linear support vector regression, and various other options. So it depends on you what model. Even in the support vector you have multiple algorithms and model options available. So it depends on you what you would like to choose from. So let's say I have chose support vector classification, and in that support vector classification, again you say shift tab and then you would see there are so many hyperparameters, or I would say there are so many parameters like this C, kernel, all these are hyper parameters which help in regulating the behavior of your model. Okay. So as of now, I've set the kernel to a different value, linear, but the default value is RBF. If you saw, I show again, shift tab, the kernel value by default is RBF. What is this kernel value? And you can just go ahead in fact read it here that there are four options for kernel. Either you set it to linear, which I had shared in the solution, or the default value, which is RBF, poly, sigmoid, and pre-computed. So yeah, we have five such kernel values, and it is also saying that your default is RBF. So what does this kernel do? Specifies the kernel type to be used in the algorithm. So if you don't give a value, then RBF will be used. If a callable is given, it is used to pre-compute the kernel matrix from data matrices. So again, this is an array that is used to regulate the model behavior. So I'll just show with the default value what change would come. Initially, I showcased an accuracy of this. Let me just restart and run the entire model. Okay. And when we use the RBF as this generating the model, and we will generate and store it in this CLF classification variable, then we will fit this model simply on our X train, sorry, on our X train and Y train. So why do we, do this? We basically, do the training of this parameters. 70% that I had kept is then used for training. So I'll just have to stop this, restart in run all. Okay. Hmm. So yeah, looks like it ran successfully. So what did we do? We have changed the kernel parameter to RBF and set it into the classification model. Then we have set our model, or I would say fit our model on the required training data. So that, I mean, on the required parameters to be used for training. We have loaded our support vector classification here. Next step is prediction. So using the CLF dot predict, using the CLF dot predict. So again, even in this you have, intercept, kernel, predict, or you have predict proba, log proba, random state. So those are the different options that are available. But since we want to go for a after training, we want to do check for the test data set, how is our model responding. So with the dot predict is what I will apply on my X test, and I will get an expected value on my prediction, under which I am saving in the Y prediction. Once I have done this, now I want to check my model. So if you see now, with your RBF model, my accuracy has gone down by 4%, which is again a huge number. In fact, my precision also has gone really down. Recall looks like a good value. And if you go by this parameter called confusion matrix, so confusion matrix is again this value and this value are the values which have been wrongly predicted. So now if you see, there are 13 values that have been incorrectly predicted by our model. So let's say, based on the features that we had in our input parameter, the model should have determined or said that a tumor is cancerous. It determined it as non-cancerous. And then what are such cases where the model was not able to accurately predict? Those are 13 such cases. So then this is again a value that we want to reduce. We want to get to the highest accuracy of prediction. Correct? So I showcased you one simple value that I changed, RBF, like the kernel value to RBF, which changed the accuracy. Let's change this to 20%, and then I will say run all. Oh my god, can you see? Look at the accuracy improvement. This is huge. With your RBF, the accuracy of the model with the training, just by manipulating the test size to 20%, and with your kernel set to RBF itself, 80% is reserved. So the maximum data you use for training, the better your model prediction could be. I think this 97.3 is a great improvement with the great recall and precision score. So, and even only three values are in error. If you see, only three from most of the chances, let's say if you add this up, 11 and 11, from the different parameters or the different features that are used to do the prediction, only three times your model has incorrectly predicted. So you see that this is an ideal case where with the RBF and the test size equal to 0.2, your model has given a very, very high accuracy of 97.3%. If I would like to change it to, say, linear, and then run all the cells and check, even here I have five values in error. The accuracy isn't that great as I got, previously. Your recall value has reduced, and so this is not the most optimum value for this model that I can get. Even with linear and 30% in the test size, okay, I will just quickly say run all. That will make my job faster. Yeah, I have been able to achieve a better accuracy with manipulation uh, in the hyperparameters. So these parameters, like the kernel setting to linear, the test size again I set from 20% to 30%, and there is this value as well, the random state. Okay, so this value random state also affects the way your data is printed. Let's say I put it to 119, and then I again run. all the cells. So again, now more values are in error. What did I change? I only changed the random state. And in fact, that has affected the way my model is responding. So you're getting, I'm trying to help you tinker with these hyperparameters. And if you see that as I get back to the same point in the solution, I'm able to improve the accuracy score. But we saw even with the linear and the parameter value to be RBF and the test size to be 20, we had the highest amount of accuracy. Yes. So this is only when three rows have, provided. And the recall value, look at it. All the values should suffix. I mean, the accuracy is great, the precision is decent, even the recall is amazing, and the confusion matrix itself has least number of values in error. So that is how we are able to get to the closest point or the best evaluation for our metric by doing a little tinkering with such parameters such as randomness, test size, the way we are splitting our data set, and the kernel parameter as a whole. You can also do a little tinkering with C. That is also one of the parameters here, which is currently set to 1, which is your support, this you see regularization parameter, the strength of the regularization, which is inversely proportional to your C, must be strictly positive. The penalty is a square 12 penalty. So if you just want to not complicate, keep it default and try to get to the closest accuracy. If you're able to improve this 97.3, do put a screenshot of the same. Try to tinker a little bit with more of the different options that are available for kernel. Do some tinkering with the random state, with the test size, and if you would see any more tinkering that you can do on your own, and you're able to get to a better result overall for these accuracy and precision recall as well as confusion matrix parameter, do take a screenshot of it, share it on the community platform with us. We would like to stay informed as to what improvement you could do, and we will send you an interesting open source enthusiast batch, okay, alongside with the certification that you will get once you apply for this stake assessment option. We would like to also share an open source enthusiast batch with all those who try to tinker with this kit and make some changes to improve this accuracy beyond the 97. If even if you are able to make the changes in the standard kit and get to this accuracy, it will be good to share with us on our community platform. So I hope you were able to get through this solution in an interesting manner. And we tried to justify how open source can help you build up interesting solutions, learn about the basics of doing predictive analysis, using support vector machines to build up a solution on classification, binary classification, and then quickly getting to set up this solution entirely onto your systems with a one click kit. So I hope all of you were able to set this kit onto your systems who are currently viewing us. Let us know your questions in the comment. We would like to take your questions now. In the meanwhile, I have one question from my community member coming up, which is a very interesting question on can SVM be used for predicting breast cancer subtypes? So yes, it can be used for predicting anything, like even if it is subtypes, which is something based on the gene expression data. And I read this newspaper, that this in the news. It got published in a study in the BMC Bioinformatics 2018, where SVM was used to classify breast cancer subtypes that was based on RNA sequence data and achieved an overall accuracy of 95.5%. So that is something that you would also read going ahead, where you can use the same technique for also doing prediction for breast cancer subtypes. We have another interesting question from our community members where they would want to know that I use support vector machines. What are the other algorithms that I can use to do this same prediction? So you can do random forest. You can use random forest where you are able to build multiple decision trees, combine their prediction to improve the accuracy. It can, random forest as a whole can be used for this classification task, and you can use any ANN as well. Artificial neural network. You can use logistic regression. You can use a very powerful algorithm, which is your decision trees, which is very simple to implement, like we just used SVM. You can also use k nearest neighbor. So yeah, any of these supervised algorithms you can use to make the similar predictive analysis prediction that we have done today. So I hope with this I was able to answer your questions. And do go ahead and check out our community platform. Post your queries on the platform so that we are able to cater to your queries. But for being able to interact with our chat feature that you see here, you should be signed up into the community platform. So go ahead and sign up yourself here, and then you will be able to use this chat feature that you currently see as active onto my screen as well. Similarly, you can also post your replies here. You can give us interesting questions here, which we can answer by signing up onto our community platform, as well as go ahead and also take your assessment and earn yourself a certificate by getting onto the take assessment option.
Thank you, Pooja, for that lovely session. For all our viewers and bootcamp participants, we hope you enjoyed the session and found the use case that was presented valuable. Please note that all of you who participated will be eligible to receive certificates for this bootcamp. In order to receive your certificate, please complete the assessment by answering two very simple questions. You can do that by scrolling down from on the same page where you're viewing the bootcamp today. You will find a Take Assessment button. Click that button and complete the assessment. You should then receive your certificates in less than a week from today. We will be conducting such bootcamps frequently and regularly. So if you'd like to stay updated with our program calendar, do join our community on community.openweaver.com. This community is where we will connect with you. It helps us receive feedback from you. It helps us understand topics for future bootcamps. But also you can use this community space to collaborate with each other, to ask us any questions and receive clarification if you'd like, or just share your projects and anything else that you would like to in the world of open source. So do join our community and also follow us on our social media channels to stay updated on information and trends in the world of open source. With that, I would like to thank you all for your participation today, and I look forward to seeing you in yet another bootcamp very soon. Thank you and good evening.